So today we're going to be doing something fun. We're going to be mixing derivatives, original functions, and graphs. So I'm sure you've seen this type of problem where they give you a graph of f and they tell you to figure out some information about f prime from that graph. In this case, we're going to be figuring out where f prime has increasing and decreasing intervals. And as we work through this, I'm going to point out the one thing that you need to make sure you keep in the back of your head, and actually the front of your head, as you work through these types of problems. And it should make your life a lot easier. So without further ado, let's go ahead and jump right on into the example. So here's the problem we're going to be going over today. We're going to use the given graph of f to estimate the intervals on which the derivative f prime is increasing or decreasing. So this is an interesting problem because what we have is a sketch or a graph of f, and we need to use that to figure out some information about f prime. So when you're ever trying to do some sort of problem like this, that they give you a graph of f or f prime or f double prime, and you have to figure out something about one of those others. So let's say they give you a graph of f prime, you got to figure out what f looks like, or vice versa, like in this situation. You want to keep one very important fact in your head the whole way through. The derivative of a function tells you about the original function's slope. So in this case, if we have a graph of f, we're given this graph of f of x. F prime, or the derivative of f, is going to be based on the slope of f itself. So in other words, if we want to figure out the height or the y value of f prime at any given point, any given x value, that would be equal to the slope of f at that x value. To figure out the y value of f prime, we would just look at the slope of f. So let's pick some random x value. Let's say x equals 0. We want to graph the point that lies on f prime when x equals 0. So it's going to be somewhere along this y-axis here. And we're going to figure out where that y value is based on whatever the slope of f is. Well, the slope of f we can figure out by just imagining some tangent line. So imagining a line that is tangent to f at this point x equals 0, like this line here that I just sketched. Whatever the slope of this line is going to be the y value of f prime. Now, unfortunately, this y-axis here is not labeled, so we don't exactly know exactly the slope. Again, we're just trying to figure out where f prime is increasing or decreasing. That's all we need to figure out. Let's just say for instance, for this quick example, let's say that y equals 1 is here, y equals 2 is here. So the slope of this line here, this red line, basically just means how many units you go up divided by how many units you go over. It looks like this line is about a 45-degree angle. In other words, you go up 1 unit and over 1 unit to get from one point to the next. So what that means is the slope of this line, or the slope of f when x equals 0, is 1. So as a result, the output of y prime, the point that lies on y prime at x equals 0, is going to be at a y value of 1. And we could do the same thing, as we go across to any x value here. If we pick, for example, a point where f prime clearly has a slope of 0, it has a local minimum here, that means y prime is going to be 0 at that point. The output of y prime is going to be 0 because the slope of f is 0 at this point. So you could kind of do that for any x value as you go along here. But what we really just need to look at in this case, since we're just trying to figure out where f prime is increasing and decreasing, what that means is, where is the slope of f increasing and decreasing? In other words, what sections of this function f is the slope getting steeper upward, or less steep, or steeper downward, or so on and so forth. So you can see right here, starting kind of from the most left point and moving our way over to the right. You can see right here, our slope of f is pretty steep in the upward direction. It's pretty high slope value, which means the output of y prime, if we're going to kind of imagine graphing that at the same place, is going to be pretty high up because our slope is very high in the positive direction. As we start moving along f in this direction here from left to right, we see that it's started out very steep in the positive direction and it's slowly flattening out. The slope is slowly getting flatter and flatter until it eventually is perfectly flat at this point. So what that means is our slope is getting less steep. It's becoming less positive. So y prime is going to be decreasing over that period of time because the slope of f is getting less steep. Well, we know that when we get to this point right here, this local maximum, we know that y prime has to be 0. The slope at a local maximum or minimum is 0. So y prime is going to be 0 right here at this x value where we have this local maximum. So our f prime is slowly going to be decreasing and decreasing and decreasing and decreasing until it gets to this point here, 0. Y equals 0 at x equals about a half or so. But now at this point we have a slope of 0. Now you can see as we get just a little bit to the right of that, we have a slightly negative slope. Our f is slowly starting to go in the downward direction. It's not very steep though at first. It's just a little bit negative, but not very much. So that means y prime is going to have a small negative y value at that point. And then we can see right about here, our function f is as steep as possible. It has the steepest negative slope that it does within this little area here. So what that tells us is that y prime is as much negative as it's going to get right here. So right about here, 1.75 or so, somewhere in that little area. So what that tells us that y prime is as negative as it's going to get right there. So y prime is going to continue decreasing until it gets to that point where the slope is as negative as possible. And then the slope again starts to flatten out and curve back upward again. So our y prime is now going to start coming back up and going back up towards 0. And once we get to this point here where f is flat, f has a slope of 0, y prime is going to have a y value of 0. So it's going to go through this point right here. So our y prime is going to continue coming up, increasing up until it hits 0 right at this flat spot here. And then again, we can kind of look ahead a little bit. Our f is going to have a flat slope right here. So y prime has to go through this point 0 right here. And what we want to look at is where does f have the steepest slope in this little section here? Well, it looks like probably right about here. F is about as steep as it's going to get. So what that tells us is that f prime is as much positive, as high, because the height of f prime is just the slope of f. So if the slope of f is as steep as possible, f prime is going to have as big of a height as possible at that point. So f prime is going to be, pretty high up, and it looks like, maybe about as steep as it was here. So probably somewhere up here, we're going to have our y prime with a pretty high positive y value because f has a pretty high positive slope at that point. So y prime is going to continue coming up until we get to this point. And then right after that, the slope of f again starts kind of flattening out a little bit until it gets completely flat at this point that we've figured out already. Y prime has to be 0. And then we can see that f, has a negative slope here. So y prime is going to have to be in the negative right here. At first, it's kind of flat, not very much steepness to it. And as you start going over more and more and more and more, you see that the slope starts getting steeper and steeper and steeper. So y prime is just going to keep going more and more and more negative as we start going further and further in the positive x direction. So we can see that our f prime would look probably something like this. Now we can see just from looking at this that the point where y prime is decreasing basically is just going to represent the interval where f goes from the biggest possible positive slope down to the biggest possible negative slope. So it's kind of curving downward. So that interval, it might be like 1.75, it might be 2. It's kind of hard to tell from this sketch. But we could say that this interval is probably something like negative infinity over to 1.75, let's just say. Again, we don't have exact, it's hard to measure exactly when you're just kind of estimating the slope. So we can see that f prime is decreasing over this interval. And then again, it's decreasing from this point here where f had the steepest possible positive slope until the point where, well, it just keeps on going to infinity. So it looks like that is about at x equals 5 to infinity. And then we have this increasing slope in between those 2 points. So it's increasing from 1.75 to 5. So these are the intervals where f prime is increasing and decreasing based on what the slope of f is doing throughout those different intervals. Well, I hope you found that video helpful. If you did, please be sure to hit that like button down below. Subscribe to my channel too while you're down there. It's a huge help so I can keep making more videos like this, and so we can keep crushing it all term long. Never forget, f prime always tells you about the slope of f. Keep that in mind, and differential calculus will be a lot easier for you. If you want to keep learning some more, go ahead and click on one of those videos over there. Thanks, and see you next time.